Hi, this is Zach Grinspan. I am an associate professor of pediatric epilepsy at the Weill Cornell Medical Center in New York City, and I am talking today about grant writing for the EpiPort clinical research curriculum. My talk is about how to find funding and how to write an Ames page. So the objectives for the talk are as follows. First, I'm going to outline the essential elements that are common to most grant applications. I'll talk about some potential funding sources and how to find them, including sources for non-US citizens. I will identify some sources of ideas for research proposals. I will describe the differences between a research grant and a mentored career development grant application. I will then take a break, and then we'll dive into the key components of a compelling specific Ames page, which is the most important part of a proposal, and those are my objectives. So let's get started. The essential elements of a grant application are as follows. You can sort of think about a grant as having four different sections that you have to work on, and that you need to budget time to make sure that you cover. The most important is the core science, and that has three pieces. There's the Ames page itself, and we'll go into more detail about that. That's really the heart and soul of the proposal. It's the brief summary of what it is you want to do, how you're going to do it, why it's important, and if you're going to spend an inordinate amount of time on one piece of the grant proposal, this is it. The core science also includes a section talking about the significance, where you can go into more detail about why your research is compelling and important. And for many applications, innovation is important. The reviewers will want to know that what you're saying is new and interesting. And then the bulk of the proposal often is a detailed dive into the methods. What is it that you're going to do? How are you going to do it? Is it feasible? Can you get it done in the amount of time that you've said, et cetera? And so those three sections are often what you think about when you're writing a grant. There's several other sections that go into your science section that you might not think about initially, but do require some time, and you can get dinged if you don't pay sufficient attention to them. So first is limitations and mitigation. No science is perfect. Every science project has the potential to fail, and it's better to be upfront about that and to go ahead and say, here are the ways that this could not succeed. And then the nice thing about that for reviewers is if you then follow that well with some text explaining what you're going to do if it doesn't work. So, I'm going to do analysis of this piece of data, but if it doesn't work, I can do a similar analysis on this other piece of data, et cetera. Similarly, every piece of science ought to naturally lead to another piece of science, and so anticipating that looks good in the eyes of a reviewer, and so having some description of what your next steps are. Increasingly, a lot of grants are asking for you to be explicit about what deliverables you're going to produce through the research, and also how you're going to tell people about your results through a dissemination plan. So this might be, for example, a list of manuscripts or a list of talks you're going to give or some other product, as well as a description of how you're going to give some talks at some national conferences, you're going to submit abstracts to different professional societies, etc. A timeline is critical, so you can communicate to the reviewer that you have thought about whether you can get the work done in this time they've given you. There's often a lot of abstracts that different funders are asking for. Sometimes there's a scientific abstract, a lay abstract, et cetera. And then you often need to talk about how you're going to protect human subjects. The finances, for me at least, are often the most stressful part of the grant, because you've got to figure out how to pay for everything that you want to do. And then once you've got your spreadsheet with all of those numbers, you need to justify it with an additional document that describes in detail each of the expenditures you're anticipating. And then there's a bunch of supporting documents. You often want letters of support from people who are going to say that your grant is a good idea and that you're the right person to do the work. You will need to do a bio sketch explaining who you are, your publication record, your credentials, etc. Sometimes grant donors want a page describing the facilities of your institution, i.e. saying whether you have the resources institutionally to do the science that you propose to do. For example, if there's some piece of equipment, either you have it or there's some place for you to put it if you purchase it. There's sometimes there's other regulatory paperwork that you need, and then the subcontract paperwork can also be time-consuming, and you should start on that early. If you are doing a multi-centered grant, each of your collaborators will need to produce some paperwork to send to you several weeks in advance of when the final application is due. Costs are complicated, and it's worth spending a little time talking about the difference between direct costs and indirect costs. So direct costs are for you and your research. That's your salary, that's the equipment, that's travel, and anything else that you need to get the research done is a direct cost. There's also a bunch of indirect costs, and those are things like rent, utilities, office expenses, etc. Often this pays for administrative staff. These indirect costs are critical for your organization, even if they're sometimes invisible to you as the researcher. And so it's important to keep these in mind. In academic institutions, like where I am here at Weill Cornell, indirect costs are often charged by the college or university as a percentage of the direct cost. So if there's an indirect cost rate of, say, 40%, that means that if you got $1 million for you for your research, $400,000 are needed in indirect costs to the academic institution to keep the lights on. Be careful, because sometimes you get grants that are direct cost grants. So you're applying for $1 million, and they give you $1 million, and then all the indirects go on top of that. So NIH grants are like that. But there are other grants that are total cost grants. So then you have to be a little bit more careful, because if the total cost is $1 million, you don't get all of it. You just get some percentage, and you have to work that out with your institution. So, as a straw man example, if some institution charges 100% indirects, and so whatever you get as research, they want dollar for dollar for overhead, then $1 million grant is half for you, $500,000 half for the college. I don't know of anybody that's got a grant that high. It's indirect costs range from like 20, I've seen as high as 70%. And so you have to do the calculation yourself. As an aside, for total cost grants, many institutions will allow you to make the argument to reduce indirect costs in order to get you more of those dollars, but that's going to be very institution dependent. So for epilepsy research, where are you going to get money to do it? I think about there being sort of two buckets of funding sources. There's federal dollars, and then there's like professional societies and foundations. A third source might be philanthropy. If, someone's going to write you a check to do a bunch of work, but that often is going to come through your college and is often a more complex or sometimes more simple arrangement depending on the donor. But let's focus on these two, because this is sort of what we think about as sort of classical grant writing. So there are some major pros and cons in applying to each of these sources. So for federal grants, the main pro is that the dollar amounts are big. There's substantial indirect costs, and so you're, for those of you in academic institutions, the dean's office is very happy when you get federal grants because those indirect rates are often pretty high. Federal grants are typically thought of as more prestigious. The NIH R01 grant is like the gold standard of an academic researcher, and a lot of the big name institutions are looking for R01 and similar kinds of grants to come in. The review process is really robust, and they bend over backwards to make it fair. You've got a room full of folks with multiple readers. You've got people who are listening in. You often get paragraphs and pages of review describing what people liked and didn't like about your proposal. It can take some time, but the process itself is something that the NIH, for example, has been very thoughtful about. And then the other nice thing about federal grants is that they're multi-year, so you can apply often for 5 years of funding, and for some grants even more. The cons are that these grants are typically very competitive. Sometimes you get pay line rates, in the 10 to 20%. There have been some years where it's even less than that. So the competition can be quite fierce. And then once you get the grant, the regulatory burden is often high. There's a lot of reporting you have to do. The reporting is often quite strict, and you have to account for your dollars very carefully. This is in contrast to grants from professional societies like the American Academy of Neurology, the American Epilepsy Society, and foundations like CURE, like the Pediatric Epilepsy Research Foundation, the Epilepsy Foundation, etc. The nice thing about these grants is you can often apply for infrastructure. That's harder on the federal side. It's not impossible, but infrastructure is sometimes harder to fund federally. There's a lot of training grants that are out there from these sources. The competition is somewhat less competitive, not always, but often the bar is a little bit easier to get across, and the regulatory burden is typically much less. The forms are easier to fill out, and they're not quite as strict about following your every dollar. The cons, these grants are often shorter. Often it's 1 or 2 years. The dollar amounts are often smaller. The indirects are often smaller as well. Some of them will restrict. Some organizations won't pay any indirect. Some will limit it to a few percent, or maybe 10 or 20%. And the review process is not nearly as robust. It's typically a single round. You might get a few paragraphs explaining what the pros and cons of your grant are. A lot of these organizations will try to mimic the federal review processes as much as possible, but it's never quite the same. And so there's some there sometimes it's frustrating because you put a lot of work into the grant, and then the feedback you get is limited. So how do you find grants? There's a bunch of different sources that are out there. Here's a list of some. So there's something called SPIN from Info@Global. Grants.gov has several tools that allow you to find grants. There's a website I found called grantome.com. Proposal Central has some grant listings there, and often they will accept foundation grants. If you have a specific foundation in mind, you can connect to that foundation itself. And then, truth be told, often word of mouth is very powerful. Looking for mentors, looking for colleagues, and talking to project officers for different organizations. And then there's some listservs out there that can be helpful to sign up for. But often it's these tools that allow you to find out that something is coming. so you can start thinking about it before the announcements are even made. For non-U.S. citizens or non-U.S. residents, many of the grants are also available to you. The key thing is just to read the fine print and understand exactly what they're looking for and exactly what the requirements are. So sometimes there's just some extra paperwork you have to do. If it's U.S. dollars coming to you, you may need to file a U.S. tax return. You want to be careful about that. You might need to get some U.S. Administrative numbers to help you with those applications, like some kind of taxpayer identification number or an employer identification number. The training grants from the federal agencies, from the NIH, are less available. The K-08 and the K-23, for example, sometimes are not available to non-U.S. citizens and residents. One exception is that there's a grant mechanism called the K-99R00, affectionately called the kangaroo, and that one is less restricted. And some foundations have limitations too, depending. So the real key is that if you find a grant application that looks compelling to you and you're not a U.S. citizen, you really have to look very carefully at the requirements. How do you find ideas? So there's a couple of ways to do this. When I was a kid, and even in like high school and college, I had this impression that like science was very secretive. You kind of had a good idea, and then you wanted to be cagey about it. But as I've gotten into research and gotten my own funding, I'm finding that the opposite is true. That successful PIs and people who have successful fundings are often very open about their ideas and their science. And it seems like the secret there is that good scientists and successfully funded scientists are looking to share because it helps them develop better ideas. So the best way to find ideas is just to talk to people, and as many people as you can find. Bench scientists, clinicians, your mentors, your peers, talk to patients, talk to funders, talk to project officers. The other thing to do is that if you get involved in collaborative research, to be a good collaborator. And it's not necessarily obvious what that means, so I would recommend finding this document that's online called the Collaboration Team Science Field Guide by L. Michelle Bennett and these two other folks. I think the Cancer Institute put this out, but it's a really thoughtful and well-described manuscript about how to work well with others. And, it doesn't always come naturally, so it's worth understanding what good collaboration looks like and then making an effort to do that. The reason is that if you're a good collaborator, then people are going to be more willing to share their ideas with you, more willing to give you feedback on your ideas, and help you shape them. The other thing you can do is you can look to see what else has been funded, and I'll talk about that in a minute. So what are some pitfalls? Sometimes you'll mismatch, and you'll send a grant out to a funder, and the proposal isn't really what they're looking for, and so it's key to look to make sure that the funder is a good match for your idea. And honestly, collaboration failure is a big disaster. So it's important to make sure that if you're going to work together with others, that from the very beginning you set a positive tone and demonstrate thoughtfulness about working together effectively. So this is going back to this idea of looking at funded research as a way to come up with ideas. Grantome.org, you can put in different keywords, and it'll show you what's been funded. So here, for example, is a bunch of R01 grants with the word epilepsy in the title, and you can then see, who got funded and what was their idea. Training grants. So the NIH and private funders recognize that in order to have ongoing, lasting, high-quality research in epilepsy, you have to teach people how to do it. And so many of these organizations have grants specifically for trainees. As an MD researcher myself, I've seen these targeted to people who are just out of training, their clinical training, and are looking to get themselves started in a clinical research or even a bench research career, and need a few years to kind of get some ideas going, get some papers out before they can truly be independent. And so you've got several flavors of these kinds of awards, both from the foundations and professional society as well as from the NIH. The real key with these kinds of awards is mentorship. And so you need to be able to get some mentors, either one or several, who are willing to support you and give you ongoing advice during this period. I have got a good colleague who talks about an effective training grant as being about the man or the woman, the plan, and the fan. So the man, woman is you, the researcher. The plan is your research question, which has to be really, really good, obviously. And then the fan is your mentor and your organization that you need to convince a funder that the work is going to get done and that you'll have sufficient support. So some examples from foundations and professional societies. The American Epilepsy Society has some early career funding opportunities. The American Academy of Neurology has a Career Development Award. And then the Child Neurology Foundation, recently there's something called the Elterman and the Shields Grants. This is money from the Pediatric Epilepsy Research Foundation, which they then funneled to CNF to give these awards. The NIH also has some career development awards. The classic ones that you're going for are things like the K08, which is really a bench neuroscience award, the K23, which is for patient-oriented research, and then there's also a K02 award, which is, you're more of an independent scientist, but it's not quite as robust as an R01. And then there is this mechanism called the kangaroo, the K99R00. The principle there is you get a few years of mentored research, and then you get a few years of independent research similar to what you would do in an R01, but you apply for both phases at the same time. The main pros of all of these awards is that it's protected time. Once you're out of these periods, you've got to fight for every minute of your day. But during these periods, you can often get, for clinicians, 75% of your time protected to do research. One of the real challenges when you're done with your clinical training for clinical trainees is that you go to an academic center and there's all this clinical work to be done, and that can really drown you and prevent you from getting your research career launched. And so the main advantage is to protect that time. The con is that the indirects are usually smaller, and so the institution is investing in you. You're providing a little bit of money for the lights and for administrative support, but it's not the same as you're going to get at an R01, and so that's just something to be careful of. When writing these grants, the main pitfall is that some people do not spend enough time talking about mentorship or their career development plan. I've heard of this happening again and again, where you're so focused on your science that you don't spend enough time thinking about your research plan. One colleague of mine, a senior colleague, said that if NIH is going to fund you on a a KOA, they're spending millions of dollars to make you into the best possible researcher for whatever topic you're going to tell them you're going to become the world's best at. And so even if your science is really pristine, they want to make sure that you're going to get the training required to become the best in the world at that thing. If you already are the best in the world, you don't need a training grant. So you have to make sure to describe that well. So I have put together an exercise which should be available to you to help with this. I took a class in my master's program where we took 5 to 10 possible sources of funding and then wrote a few sentences about it. And this is a reasonable exercise to do, to spend an hour or two doing, because it really can help guide you. And what you do is you take 5 to 10 possible sources, you purposely read through the call for submissions, and then you jot down, what's the purpose of the grant, who's the target audience, how much money is it for how many years, what are the dates, what are a couple of ideas you might submit to them, when and why you might apply, and then reflect a little bit on the pros and cons. All right. So this is after the lecture break. And what the next group of slides are going to focus on is the aims page. I was asked to talk about the grant itself, but most of these slides are focused solely on the aims page because this is clearly the most important part of a grant. Think about this as a call to arms. You're saying that your research is a moral imperative. You're advertising yourself and the work. It is a manifesto for how you think, for why you think the science is important. You have to show how your research question is compelling and urgent. The text itself has to be concise and streamlined. The aims page is the first thing that you write when you are submitting a grant, and it should be the last thing that you edit because this page has to be perfect. You know you're on the right track if you're thinking about your aims page when you're in the shower in the morning. It has to be perfect. Don't misspell words, and make sure your grammar is perfect. I would advise reading Strunk and White's The Elements of Style cover to cover. It is the most beautiful and concise description of good writing that I've seen. I would particularly recommend Rule 14 and Rule 17 to use the active voice and to omit needless words. And then there's some lovely text about an approach to style. Write with nouns and verbs, revise and rewrite, and be clear. Let me just read a quote because to me this is inspiring. Vigorous writing is concise, says E.B. White. A sentence should contain no unnecessary words, a paragraph no unnecessary sentences, for the same reason that a drawing should have no unnecessary lines and a machine no unnecessary parts. This requires not that the writer makes all sentences short or avoid all detail and treat subjects only in outline, but that every word tell. And there's other lovely sections in this book. You should be clear, clarity, 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 he writes. If you become hopelessly mired in a sentence, it's best to start fresh, etc. And so the reason that I'm going through this is that I want to emphasize again and again how important the aims page is and to make sure that you're really devoting sufficient energy to getting that page right. All right. I've come up with an outline that will help at a high level think about what goes into the aim page and how you're going to weave this story. one way to think about it is to call it the poppy. So you're going to talk about the problem and the gap, the opportunity and your idea, your plan, aims, and hypothesis, and then the impact of the work. So let me go through these and let you see how they play out. So here's an aims page from a successfully funded grant. The details of the text are not as important, but I want to show you kind of how this plays out. So it starts with the problem, highlights a gap. It talks about another problem and another gap. Then it goes into talking about the opportunity. And then right there in the center of the page, there in bold, is like your idea. This is what your grant is about. Some people call this the central hypothesis of the project. And then I have found it is effective to, at a high level, talk about your plan, what it is you're going to do. Then you go into your aims and your hypotheses, and then don't forget to have a few lines of impact at the very end and to make space for this, because you want to make sure that the reader knows why what you have proposed to do is important. So, problem. The first thing you say in your grant is, what is the terrible thing that you want to make better? And your audience is a high school biology teacher. This is sort of lay public kind of words. And it's one or two sentences. So here's an example for one of my grants. Rare epilepsies are a devastating, heterogeneous group of diseases that begin in childhood. Affected individuals are a vulnerable and complex population with profound neurologic, medical, and psychiatric disabilities. So as soon as you read that, you're like, wow, these kids are a mess and I want to fix them. So that's the purpose here. Some people will cite statistics and things like that, and that's also okay. The pitfalls is some people just omit this. They kind of just dive right into the science. Sometimes it's too narrow, and you focus on a very, very small issue without putting it in larger context. Sometimes people are too technical, and they start talking about, specific genes and how they interact with other genes without laying the stage for why it's important. And then other times it's not linked to human health or disease. If you're submitting to the National Institutes of Health, you have to show why this is related to humans' health. So then the gap. And interestingly, for junior faculty, this is often the hardest. They can kind of identify the problem, but they have trouble articulating the gap. So the main thing here is, what do we know and what don't we know? And what's the gap between those things? So the audience is a little more technical. It's like a neuroscientist that you don't know. And the length is maybe one or two sentences, although sometimes you need a full paragraph to really flesh out what the gap is. So here's an example from that same grant. There are reliable epidemiologic estimates for only a few of these diseases. Tuberous sclerosis, for example, affects one neonate per 5,700 live births. That's what we know. However, for some diseases like Aicardi syndrome, estimates are limited to counts of known cases, 900 in the U.S., and for others like MRF, there are no estimates at all. So there we've said very concisely, here's something we don't know, here's something we do know, and here's something we don't know. This is a longer example of the gap. I won't read it, but this is for a grant where there were 3 aims, and I wanted to highlight the gap in knowledge for each of those 3 aims way up in the first paragraph, or the first section. And so here's an example where I just kind of walked through those 3 things. Pitfalls. A lot of people just like to say, no one ever did this before, but that is not sufficiently compelling. It's not enough just to say this hasn't been done. You have to say why it's important to do. Sometimes the gap is implied, but it's not explicitly laid out, so you got to make sure that that's laid out as well. Beware of being too technical. People have done this pressing button A on this machine but not pressing button B on this machine. You want to make sure that the gap is sufficiently conceptual that a general neuroscientist will be compelled by it. And then some people will kind of list out literature without synthesizing it. So this study showed this study showed this study showed this, but it's not enough just to list those papers. You got to say at a higher level, these papers showed something, but they didn't quite address this, or this is a thing that they didn't talk about and it's important to do. Then you want to talk about an opportunity and your idea. And the opportunity sentence or sentences is not something I've seen in other grant presentations, but I found it to be very, very effective. The idea is you want to say that there's something fun, new, exciting that's happening now that is why this should be funded now, and why it wasn't done like 20 years ago, and why you don't want to wait until 10 years from now to do the work. The audience, again, is a neuroscientist, field independent that you don't know, and sometimes it's one or sentence or two, and sometimes it's a full paragraph. Here is some text from a different grant that I wrote. There are new opportunities. Oh no, this is the same grant. There are new opportunities to study these diseases. First, broad use of EHRs, blah, blah, blah. Second, the Rare Epilepsy Network, blah, blah, blah. Third, and so what happens here is there's a sentence that says there's new opportunities and it explains what those are. The opportunity can be you. You've got data, you've got methods, you've got training, you've got a track record, and so that can often check the opportunity box. So here's an example. Our prior work found that natural language processing can reliably identify risk factors for SUDAP. So that's another grant application I put in where the success of the prior work is laying the foundation for the work you want to do. And the other thing, particularly with private funders and foundations, is you may want to explicitly call out their mission statement because it communicates that you've read it and that you're trying to align your work with theirs. So here's a grant that I put into CURE. It wasn't funded, but it's here for demonstration. Our work fits squarely within CURE's mission to cure epilepsy and thus transform and save lives. The thing here is that there is an idea. The idea has to then come through. So some people call this the central hypothesis, and the audience is a scientist you don't know. Notice that it's not a neuroscientist. The central hypothesis has to be sufficiently broadly described that anybody who's got some scientific savvy will find it compelling. So here's a grant where we said our central hypothesis is that text processing of clinical notes will improve surveillance and epidemiology of the rare epilepsies. And then here's another one. Our central hypothesis is that we can lower emergency department visits, reduce healthcare costs, and improve seizure control for children with epilepsy by predicting which children will become frequent ED visitors and then providing those children with a care management intervention. Pitfalls. Sometimes people don't include their central hypothesis. Sometimes it's not clear. Sometimes it can be too technical. And then sometimes it's not obvious why it's important. Your central hypothesis should stand on its own and convince a scientist who may not know your field. It should convince that person why this research is potentially impactful. And then I'll often put in a little blurb about the plan. We will use New York City CDRN to find affected individuals using EHRs from multiple centers. We'll describe the incidence, prevalence, comorbidities, mortality, and insufficiency of ambulatory care. And then we'll develop, characterize, and disseminate regular expressions to find individuals via analysis of clinical notes. So what those three sentences do is they at a high level lay out the flow of the whole proposal, and then the aims that happen next go into more detail. All right, the aims. So again, the audience is a neuroscientist you don't know, and these should be pretty perfect. It's often an aim is just a single sentence, but sometimes you add a second for key details. So here's an aim. Develop and evaluate a predictive model to identify future frequent ED visitors. among children with epilepsy via machine learning techniques using clinical and administrative data. So notice how it's got a lot of pieces there. It starts with a verb. You know what's going to happen. It's a predictive model. There's some definitions that have been slid in there so that the reader knows how you're going to operationalize different topics. And then the methods are also implied via machine learning techniques, as are the data sources. And then your hypotheses. So again, a hypothesis should be a perfect sentence, sometimes a second sentence for key details. And they need to be specific. So here's an example. A claims-based case-finding algorithm for infantile spasms will identify cases with better than 80% sensitivity and positive predictive value compared to a gold standard at 4 centers. So again, implied in the hypothesis is a description of what you're actually going to do. The more you can communicate about your methods implicitly through your aims and hypotheses, the better. There are a lot of pitfalls that I've seen in how people write their aims. One of the main things that funders get worried about is if your aims are dependent. And one of the most common flaws is that aim 1 is I'm going to develop some test, and then aim 2 is I'm going to apply the test. So you can't do aim 2 if your test didn't work. And so the way to do that is to make sure that your application of the test either is a separate grant or can proceed independent about whether the test in aim 1 succeeds or falls. Another thing is that sometimes people will throw in like a new clinical concept in the aims, and it's not mentioned at all in the text above. So you should be clear that any concept that gets mentioned in your aims appears somewhere in the explanatory text above. Some aims aren't testable, they're just descriptive. There's this thing called the finer criteria, and people are either explicitly or implicitly checking these boxes when they read your aims. Is your research feasible? Is it interesting? Is it novel? Is it ethical? And is it relevant? Some aims are wishy-washy. We think we'll get this. We hope to do this. This may... and so clean up the language to make sure you're definitive. And then this is an example. Some people write, we hope, blah, blah, blah. Use something more like we expect or we anticipate. I like to start aims with verbs. Not everyone does, but to me it makes it all about action. And then there's the perpetual bugaboo of insufficiently ambitious or too ambitious. And the only way to get a sense of that is by having more than one person read your aims page. Review committees are often looking for people who are asking for a lot of money to do something really easy, or asking for very little money in very little time to do something that's clearly too broad and will take more than what they've asked for. And then an impact statement. I started to think about this impact statement as being aimed to parents. As I'm a pediatric epilepsy researcher, and not just any parents, but like sophisticated parents with a PhD who fund research. And there's a lot of them out there. There are a few outspoken ones, but there's a bunch of folks who are involved in advocacy groups and who have advanced degrees and who raise money to research the diseases that their kids have. And so if you can convince them that your work is important, you can certainly convince a review committee. So that's the audience, and the length is a brief paragraph. So here's an example. It's a little bit long, so I won't read it. But what this does is, let's see. I'll read, so this like the middle sentence. The observation that 1 in 7 affected children are initially given therapies with inferior efficacy underscores the pressing need to conduct and publish rigorous comparative effectiveness research and disseminate the findings. So, you're selling your research here and you're talking about why it matters. Here's another example, and I'll read the first sentence. Improved epidemiologic estimates will guide clinical care, prioritize research initiatives, spur development of therapies by industry, and help caregivers understand these devastating diseases, etc. And then in this impact statement, because I must have been going for a federal funder, I then took a minute to explicitly align with recommendations from an Institute of Medicine report and from the National Institute of Neurological Disease and Stroke Epilepsy benchmarks. I've seen this omitted, and it's important to make sure you keep it. Sometimes the impact statement doesn't express the importance of improvement of human health, and then wishy-washy comes here all the time. This may help. It's possible that. Avoid that wishy-washy language and be more definitive about your work. If you're not convinced that your work is going to be important, a reviewer certainly is not. So what do you do then? You've written your aims page, you've taken showers for a week and thought about it every day. What do you do next? I won't cover all the details, but the one piece of advice that I would do is the two pieces of advice. One is use your aims as guideposts, and two is draw pictures. So here are two figures from different grants, and the first thing I would call attention to is that there's this natural flow of some of the things that I talk about in the text and how they connect with one another, but also that there's an explicit linkage between the arrows in the pictures and the figures to the different aims. Reviewers love this because it shows that you can provide a high-level conceptual overview of what you're doing, and then it shows the reviewer where in the text of your grant to find information about particular links. And then a final piece of advice, the request for proposals often has a lot of juicy details about how the reviewers are going to rate your grant. I remember being on review committees where you essentially are asked to go through like a bunch of check boxes whether they have followed all of the instructions that are in the RFA. So there's often some subtle stuff that can be easy to miss, and throwing in a few sentences here and there that explicitly respond to each and every request in the request for proposals is really worth an investment of time, and it can take a few hours to do. So don't minimize how much time that could take. So that's the end of my talk. Thank you all for listening. I hope this is informative. And then in the slide deck, there are some additional resources linking to advice on grants from the NIH, from foundations, and from professional societies.